Friends, let us discuss another refrigeration technology, namely steam ejector refrigeration system. This steam ejector refrigeration system has a steam ejector, which is the core part of this system. Along with the steam ejector, the other components are the vapor generator, also called as boiler, the condenser, the evaporator, and to maintain the pressure difference, there is a liquid pump and an expansion valve. Now, this all components together would create the cooling effect in the evaporator. So, cooling effect is created in the evaporator, and this is created not because of electricity supplied, but because of heat which is supplied in the vapor generator. So, this is the heat driven technology. You are supplying heat in the boiler and you are getting cooling effect in the evaporator. Uh, Instead of compressor, we have a ejector, right? Instead of compressor, we have a ejector. Now, how this technology creates cooling effect in the evaporator? For this, we need to understand that this technology operates under three pressures: the generator pressure, which is 1 to 2, or we'll call it as P generator, PG. Then the intermediate pressure, which is P4 is equal to P5, which is the condenser pressure, PC. And the lowest pressure is in the evaporator, which is P6 is equal to P3. We'll call it as evaporator pressure. Now, in this technology, steam is the working fluid, and steam is generated in the boiler. This steam which is generated in the boiler is at a higher pressure. This steam is called as the motive steam. This steam is called as a motive steam. What happens to this motive steam is this motive steam enters the ejector. When the motive steam enters the ejector, this steam is accelerated in this nozzle. You see a nozzle over here, supersonic nozzle. So the steam is accelerated in this nozzle and it reaches the supersonic velocity. When the steam reaches the supersonic velocity, it creates a depression or vacuum at the nozzle outlet, and when there is a vacuum or suction created at the nozzle outlet, suction is created and another steam enters into this nozzle. So that steam would come from the evaporator. Okay, so this evaporator steam is sucked in into the nozzle. What happens next is both these flows would mix. Okay, they would mix in the mixing chamber. When they mix in the mixing chamber, they would now come to a constant pressure, and finally there is a diffuser where the pressure is regained. So what happens in the ejector is, first the primary flow, which is the motive steam, it is entering the ejector. It creates a supersonic velocity steam, as a result of which there is a suction which is created. Suction would result into the steam getting into the ejector, the steam from the evaporator getting into the ejector. Both the steams, that is the motive steam and the suction steam from the evaporator, they are mixed in the mixing chamber, and finally the pressure is regained up to the condenser pressure in the diffuser. This steam, mixed steam at the state 4, is condensed up to the state 5 by rejecting the heat to the surrounding. Partially, this steam would be pumped back to the vapor generator for recirculation, and the remaining steam would be expanded into the expansion valve up to the evaporator pressure. This steam, when it comes to the evaporator, it is at the state 6. It would absorb the heat and create cooling effect and come back to the state 3. So this way, this refrigeration loop would operate. That is, the steam at 6 would come to the state 3. It would be sucked in into the ejector, get mixed and come at the state 4. It would be condensed in the condenser. The condensate is then expanded in the expansion valve. So this is your refrigeration loop. In the power loop or in the high pressure loop, what you have is the steam at state 4 being condensed to state 5, then it is pumped back to state 1 in the pump. In the generator or boiler, it is boiled and we create a motive steam, and this motive steam is then expanded into the in this supersonic nozzle up to the state 3. It gets mixed and come back to the state 4. The state 4, it does the condenser and comes to the state 5. So this way you have two loops. One is the heat engine loop or power loop where the heat is being supplied, and you have a refrigeration loop where you get the cooling effect. This is a heat driven system. Unlike your vapor absorption system, it also has a lower coefficient of performance. How is the coefficient of performance defined? Coefficient of performance would be defined as the refrigerating effect which we get in the evaporator upon the heat which is supplied in the generator. This is an interesting technology called as steam ejector refrigeration technology. Thank you.